Hey there, gearing up for those IT board exams? Well, you are in the exact right place. Today, we're decoding the memory unit piece by piece to make your exam prep an absolute breeze.
Okay, let's dive right into this. Here is our roadmap. We've got 1. Meet the memory unit. 2. Primary memory, RAM and ROM. 3. Decoding types of ROM. 4. The power of secondary memory. And 5. Comparisons and quick revision.
Section 1. Meet the memory unit. Think about the CPU for a second. It is constantly processing data. But what exactly does it do with all that data? And where does it keep it?
That brings us to our core definition. The memory unit is a part of the CPU that stores data, instructions, and processed information. Basically, it's the ultimate workspace of the CPU. Just like you need a desk to lay out your books and papers while you study, the CPU needs a workspace where all the processing action actually happens.
So what exactly is sitting on that desk? Well, it holds input data, program instructions telling the computer what to do, intermediate results that pop up mid-calculation, and the final results once a task is fully complete. If you want to lock in a core rule for your exams, just remember this: memory equals the storage of data and instructions.
Section 2. Primary memory, RAM and ROM. We know what memory is now, but how is it officially classified? Let's mentally split the whole concept of memory into 2 main branches. On one side, we have primary memory, which is also known as main memory, and on the other side, we have secondary memory or auxiliary memory. Every single storage component falls under one of these 2 umbrellas. Let's zoom in on the first one.
Primary memory is the main memory of the computer. Its defining characteristic is that it stores data and instructions that are currently being used by the CPU, right this second. It's extremely fast, it's directly accessed by the CPU, but it has limited storage capacity and it's definitely costlier to produce. Under this umbrella, we have 2 subtypes, RAM and ROM.
First up is RAM, Random Access Memory. RAM is a temporary, volatile memory used to store data and programs while the computer is working. So when you have a Word doc open or you're playing a game, those are running in RAM. But because it's volatile, if the power goes out, all that data completely vanishes. It essentially has the memory of a goldfish the second you pull the plug.
Now contrast that with ROM, read-only memory. ROM is a permanent, non-volatile memory. It doesn't care if the power goes out. Your data remains perfectly safe. It's mostly read-only, and its primary job is storing the important instructions required just to start the computer up.
Section 3. Decoding types of ROM. ROM is permanent, but there are actually 3 specific variations you need to know.
Here's how they break down. First, PROM, programmed only once. Next is EEPROM, erased using UV light, reprogrammable. This one is wild. You actually have to blast it with ultraviolet light to erase it. It's like a sci-fi memory wiper. And finally, EEPROM, erased electrically, rewritten many times. Instead of UV light, you just use an electrical charge.
Section 4. The power of secondary memory. Let's jump back to our other main branch from earlier. If primary memory is the active workspace, secondary memory is where our digital files live permanently. It's used for permanent storage of large amounts of data and programs, even when the computer is switched off. It's non-volatile. Now, it is slower, and the CPU accesses it indirectly, but it makes up for that by boasting massive storage capacities and being super cheap.
Some examples of secondary storage you probably use every day include your hard disk, an SSD or solid-state drive, CDs, DVDs, Blu-ray discs, pen drives, and memory cards. They are all built for keeping massive amounts of files safe long-term.
Section 5. Comparisons and quick revision. Let's synthesize all this into an ultimate exam prep toolkit. When you get a question asking you to compare RAM and ROM, you want to hit these points. RAM is temporary, ROM is permanent. RAM is volatile, ROM is non-volatile. RAM is for read and write. ROM is mostly read-only. Data in RAM is lost when powered off. Data in ROM is not. Finally, RAM is faster while ROM is slower. Walking through this step by step is your ticket to a perfect 3-mark answer.
For primary versus secondary memory, the contrast is just as clear. Primary is main, secondary is auxiliary. Primary is faster, secondary is slower. Primary has a smaller capacity, secondary is much larger. Primary is costlier, secondary is cheaper, and primary has direct CPU access, while secondary is indirect.
Okay, rapid-fire revision time. Let's hit some expected board questions, starting with the 1-mark questions. Try to mentally answer these right now. Define RAM. Define ROM. What is primary memory? What is secondary memory? You should be able to confidently rattle these off by now.
Next up, the 2-mark questions.
State 4 characteristics of RAM. Name 4 examples of secondary storage. Name the types of ROM. Test yourself. List that volatility for RAM, name those everyday drives for secondary storage, and recall those 3 ROM acronyms we decoded.
Finally, the heavy hitters, 3- and 5-mark questions.
Differentiate between RAM and ROM and primary and secondary memory, and explain the classification of computer memory with a neat diagram. Remember, those tables we covered are your 3-mark answers, and our top-down memory tree journey, that perfectly answers your 5-mark diagram question.
Next up, memory measurement units. Bits, nibbles, bytes, KBs, MBs, GBs, TBs. You have officially mastered what the memory unit is and where data lives. But it leaves us with one fascinating question. How exactly do we measure the size of all that data? How many ones and zeros does it take to save a photo? We are going to uncover exactly how that math works in our next explainer. Keep up the awesome work, and I'll catch you then.